Hi, it's your average Haskell girl Tuula. So I have been tinkering with the Space Garden in this past week and mainly working on how I do the uh, textures and tile sets and such. So I did a little bit of cleaning up and now my assets are divided in three folders. There's the maps containing the different maps, textures that contains the fonts and all the textures that aren't used in any tile sets. And then there's the tile sets folder that contains both the tile set definitions and the textures used in those. And on the code, when I'm loading stuff, it all starts in the main function. So here we have tile textures is load tile textures, and here I'm just opening the assets/tile sets, filtering out all the PNG files, and then just loading the textures. And I'm always returning a file path texture tuple so that I have information which texture has been loaded. And those I'm placing in my app type. There's the texture styles that will contain those. So now I can have an arbitrary number of textures in that folder, and the program will automatically load them. Of course, I'm also freeing them at the end using the destroy texture. I'm just mapping through all the entries in the list for those. And then the actual loading of the levels well, the level loading isn't changed really, but the tileset loading is quite a bit more different. We are using the load tilesets function here, and previously I was loading hard-coded files, but now I'm again getting the content of that tilesets directory and filtering only the JSON files. And for those, I'm reading the binary and returning it. So, and I have a path and the file. The tileset is a JSON file because we are after getting the JSONs, we are using here either decode strict. So this one turns them to the tuple of file path and JSON, no, not JSON file, but yeah, JSON file, tileset. And then, does it? No, no, here, sorry, pretty confused here. Here it's a file path and then a binary file. And this one is turning that with the either decode strict to the file path either string tileset. So if everything went fine, we have a tileset, otherwise we have a string telling that something went wrong. And then we are just taking all the writes and returning those if we don't have any errors. Otherwise, we are returning the errors. Yeah. Right. So this is how we load the tile sets. And now that we have tile sets, if we have the tile sets, if we don't have the tile set, we report error and exit. But if we have the tile sets, then we load the title map and game map. And here we have to pass in the textures and tile sets when we are loading this map, because we are doing some neat things here. First, we are loading the JSON here, basically just reading the binary file and decoding it. Then we are taking that JSON file of the map, JSON file of the tile sets, all the textures, and passing them here, tiled to level. And here we are taking that generic tiled information and turning that into the level. Level is our own file, I mean our own type. And we are picking the name of the level, size of the level, and then the different layers and texture sets. And texture sets we are doing with this one. We have to turn the, well, the problem is that the map has a link to the tile set, and tile set has a link to the texture, and we don't want to follow those links during the rendering, so we are doing it here. And then tile sets have icons starting from the 1, and if you have 2 tile sets, you cannot have the 2 same IDs. So we have to figure out lower and upper bound. So when we have a tile number 1, it refers to some tile set, and tile number 50 refers to another tile set. So all this information is related to that. I actually think that I explained this last time. Anyway, so we are loading the maps and tile sets and everything. And then in the user interface is where we are doing the rendering. Yeah, I explained this last time, so I don't have to explain it now. But the main point is that now I have a dynamic loading. I can just drop in the tile sets and respective textures into that tile sets directory, and the program will load those. And if any maps refers to those tile sets, they are taken into use automatically. Render map is fairly similar what it was last time. We have a bit more layers, and then we have this render animated layer. I was debating if I should have all the animated things in their own layers as a tiles, or if I should have them as objects. And then I decided that there can be quite a bit of quite many animated things on screen, and it's easier to handle if they are on their own layers, because then rendering is basically just rendering multiple layers. Some of those are animated instead of trying to, well, basically it wouldn't have been that much more different if I had say a list of objects that I need to render on some coordinates. Anyway, I decided that I want to do animated layers this time. So there's order of layers is of course important, because we start with the background. On top of that we render foreground. On top of that we render ladders. On top of that we render plants. Then we render player. Then we render grass. And then last thing is we render fences. And all of this is rendered on top of the parallax effect that I was showing last time. So that means that if we have if for example player is walking in grass, their feet sink into the grass. They are hidden from our view because player is rendered first, and on top of that is rendered grass. And if there's a fence, then the player walks behind the fence. And the animated layer is rendered. All the tiles that are in the animated layer have exact same amount of frames, and the animation is running in sync with each of those tiles. So it sort of emulates, looks similar than, for example, how animated backgrounds were done in entertainment system. You basically had tiles on the background, and then you were switching the bank where those tiles were loaded while rendering. So you didn't have to change the actual level at all to animate. You just switch the memory bank where the graphics were loaded, so that animated the whole background in one go. It was very fast. But the drawback is of course that everything has to be rendered at the same amount of frames and at the same speed. So tick here is the milliseconds elapsed since the game started, and we are just calculating what frame that would be, because we are just taking the remainder of tick divided by 1200. That's the length of the animation in milliseconds, and then we are taking the quotient when it's divided by 200, because the frame length is 200. That gives us which frame it is currently. And that information we pass in the animated layer. And in the animated layer, this is the almost identical to the rendering the layer, except that we checked if the tile is different than 0, meaning it's not an empty tile. Then we call the render tile, and instead of passing it the tile number, say for example tile number 1, we pass it the tile number plus the frame. So if the frame is 0, it is the first frame, then we are rendering tile number 1. But if it's the second frame, then we are rendering tile number 2, and so on. So it's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So it just keeps looping. And all this happens in sync. And what does it look like? It's like this. Like you can see that all the trees are waving at the same speed. All the grass is waving in the same speed. All the tentacles are waving at the same speed. So everything is moving in sync. And that's the decision I made, because it made the animation a lot easier and rendering a lot easier. If things weren't moving in sync, that would mean that I would have to keep track in which frame each of these objects is. And most likely they would be running more or less sync anyway. So why not just decide that everything runs in sync and just be done with that. And on the left you can see there's that on the middle level there's that tree that is behind of a fence. That's the layering that I was talking about. There's a tree that is behind of the grass that is behind of the fence. And the support poles and support ropes of the bridge in the middle, they are behind the grass too. So I think that is pretty nice effect. So this is what this thing currently looks like. Then I have been working on the actual level. This is what the play level will look like. On top left there's the player character. You can move it, but it's not animated yet, and it goes nicely behind of the support poles like this. But the actual animation and moving isn't implemented yet. Like the poor fellow can only move into one direction, and it doesn't go over the ramp. It just goes through everything, and then into the space, and then disappears into the void. but that's something that I will be working next. So how I'm going to read the input and how I'm going to process that and how I'm going to deal with the collisions and such. And what else? So yeah, that's the next thing. I'm pretty happy how the new tileset turned out that I drew. I don't know if I need to add more tiles into it, but it is pretty nice, I think. I have been using the A sprite, and I'm fairly happy with that. I'm absolutely happy with that. Do I have that? I don't have that running. Anyway, I can show that at some point. That is really nice program. I'm using the beta release that has a support for the tiled map, so you can actually draw complex maps, and then the program will split it automatically into tiles and reuse tiles wherever it can, and it is fairly fancy. But how I have been doing the user input? So the thing is, I had actually quite a bit problem trying to wrap my head around this. So I have handle events game running that is called from here, handle events. So the run, here is the run. Here somewhere we have here we have the up loop. This is the heart of our program. This is really simple application loop because we are not doing any fancy multi-threaded things. We are not doing any complex message passing or anything. It's basically we just render on screen what is currently happening. The state is the game state. It can be either the main menu or it can be the game running, and then depending on which one it is, it has a slightly different set of data. But anyway, render will render that on screen. Then we poll events. So all the events that has happened during the rendering, or all the events that have happened since we last called the poll events, are in the events list after this call. Then we are doing the handle events for the state and events, folding through them. So we are taking the first event from that list, taking the current state, folding them together. We are getting a new state. Then we are taking the next event, applying it to that state, next event applying that to the new state. So we are just folding all the events into the game state, transforming the game state as we progress. And we get the user input is pretty stupid name for that. It should be a new state or something, but new state was already used, but anyway. So here we are handling the inputs. Then we take the ticks. So how much time has elapsed since beginning, and we are calling update to update the state. This is because this line will handle all the user input. So if player is pressing the buttons, you manipulating the controller, this handles those. But if the user doesn't do anything, then this update, I mean even if the user does something, but in case when they don't do anything, the update will do the one more update, because we need to animate the background regardless of if the user is pressing any buttons. We need to calculate things like falling regardless if the user is pressing any buttons or anything. So this does the last update. And if we are in exiting, then we just return Otherwise, we are just loop back and do the same thing over and over again. So user input, auto, and the handle events basically goes here. So here we are, if we are asking quit, either closing the window, hitting the ESC, then we are just exiting the. No, actually, if the quit request, it's just if we are closing the window or if the OS has requested our applications to stop, then we go here. Otherwise, we just delegate our event handling to the whatever place it needs to be done. And here we have just a big guard statement. So if we are pressing the escape, then we want to go back to the main menu. If we are pressing the right, then we are updating the game control state right to be true. So there's basically six variables in that game control state, telling if the player is currently pressing to the right, left, up, down, jump, or watering button. And when we are pressing down, we set that variable to true, and when the key is released, we set it to the false. This we need to keep track of the control state because, for example, when the game starts and the player presses down for the first time, then event is generated, but if they keep pressing the button down, the next subsequent events they might be other events coming from the game system, and those events don't contain the information if the button is pressed down or not. So we have to keep track of it, because we can have multiple events during the one frame, and if we were to release the button in our application logic as soon as there's an event that doesn't tell that we are pressing the arrow down, then the player would have to keep hammering the buttons to move, and that would not be very nice to play. So we just have to keep track of what buttons are being pressed or released. And then actually I seem to have a bug here. I think I should have this one, maybe. I'm not calling simulate. Anyway, so we are actually, we can just change and see what happens, because the thing is that we want to I'm not my idea was that I want to simulate, update the state of the world every time an event happens. So when there are events coming, the time step is very small between the events, and we are just simulating what happens during that small frame of time. And when the player isn't pressing any buttons, then the time step between the simulations is as big as it takes the screen to render. So we might be rendering multiple times. Yeah, it's working still. So we are simulating what happened to the world since the previous simulation was done, and the time step is calculated from the previous simulation to the timestamp of the event. So if there's a if there's a two events coming and not at the exactly same time, let's say they come in 1 millisecond apart, then we simulate the word twice, first for one event and then for the another event. And what the simulate actually does, it should be some, actually it's there. It says to do implement properly, surprisingly. So basically here we are just checking the control state, what buttons are being pressed, and if the right button is keeping pressed, then the player location x coordinate is updated with the time delta time divided by 25. This is the speed the character moves, and delta time is just the current tick minus previous tick. And we of course have to update the game tick to tell that the previous simulation done was this one. So we are simulating in small increments when there are event comings. When there are no events, any events coming, we are simulating once per frame. And this is simple enough way of doing things, but this has the thing that it's not deterministic in a sense that if you have two computers running at a different speeds, they are going to get a different results, because one is running the simulations faster than the another one. We are doing some floating point arithmetic, and from that we are getting a compounding error. Like if you keep adding to the floating point very small numbers very many times, you are going to get a different result than if you are going to add bigger numbers with fewer times, even if on a paper the calculation should be the same, because with floating points you don't have arbitrary precision. But I decided that that's not a problem, because this is not a multiplayer game, this is not networked game, this game doesn't use very complex physics, so I can live with that. So basically here, when I get around to doing that, I should do the simulation properly, like see what buttons are being pressed, what's the current status of the player, and then what's around the player, and then based on all that information calculate where the player is moving. And I'm not going to have any creatures moving in the game. The player is going to be the only moving, the player is going to be the only moving object. They are going to walk around the level, water the garden, and watch how the plants grow. So this isn't going to be even a real game in a sense that there's not much to do, there's no challenge really, but this is just me learning how to do tile maps and how to handle user input and how to deal with the climbing stairs and such things. And I'm also using a constant speed for the player, like the player is always moving the let's see, ticks are in milliseconds. So, well, player is moving some pixels per second, but the speed is constant. There's no inertia, there's no acceleration, nothing fancy like that. When they are going to fall, I'm probably going to make the fall to be at the constant speed too, because it's just so much easier. In a more complex game, I probably would try to simulate the mass and the forces a little bit, so that when the player starts moving, they slowly pick up their speed. Not very slowly, that not so slowly that it will be annoying, but there should be a short phase where they accelerate to their speed. And if they are running, then they can go to the higher speed, but it takes a little bit longer. And when they are running and then they suddenly decide to start running to the opposite direction, first they have to slow down, and then they would come to halt, and then they will start accelerating to the another direction. All this would happen in sub-second speed, like it should take maybe a half a second, maybe not even that much, to change your direction from the full run to the running at the full speed at the opposite direction. Maybe it depends on how fast you can actually go, but there should be a noticeable slowdown, like braking and then accelerating again movement. And then the jumping would work in the way that if you hit the jump button really briefly, you do a small jump, and if you press it longer, you make a bigger jump. And if you are jumping from the full speed run, then you can jump even higher and even further. Things like that should be taken into account. And if you are carrying something heavy, maybe that will change your running too. If you are like how quickly you can run and how fast you accelerate, and if you're on a slippery surface, that will change things. Or if you are running up or downhill and all that, it will be pretty interesting, but it would also be quite a bit more complex than I'm ready to deal with right now. So I'm just dealing with constant speeds and instantaneous speed changes here. And that's what I'm going to do. I'm going to show this one still. This is the new tile set that I created. There's the ground tiles, and then there's the grass tiles. Let's zoom a little bit closer. This shows how they are defined. Like there's a one thing per row. Each row contains 6 images. That they are the different frames of the animation. And you are just plopping the first item down. You could plop this item down on the map too, but that would confuse the engine, because it would first render these 3 tiles and then these 3 tiles. So your thing will suddenly switch to the different thing. Actually, I can just show what happens. So we go to the plants layer and plop something silly in the bridge there. Save, and here's the thingy. Like now you see how the plant in the middle of the bridge is changing between 2 things, because it just takes the tile ID and animates it using the 6 frames. So that's not a good idea. I mean, maybe one could use it for something, I don't know. And the another thing is that the tiles are 16 times 16 frames, and this tree here is so tall that it's actually made from 2 tiles. Again, I could just plop this one here, and then I would have a smaller tree. Maybe actually even do that in the game. But when you have a grown-up tree, you have to first plop in the stem and then the upper part. And you can see that the animation is done on both of these tiles. And they are lined up so that the branches or tentacles or whatever are waving, so that they are upper and lower part are following each other. This is another reason I chose to animate them in sync, because then you can build bigger bigger things out of the small tiles, and they are automatically in sync. And animation is so much easier. Actually, I spotted there's a. The thing is, I'm placing all the object by hand, and here you can see there's actually that tile seems to be incorrect because I have three. I have this one. Yeah, it should be. No, actually, these are the incorrect because there's that pixel on the top left is wrong, like this, and like this, and that one is incorrect too. That's the. Hey, I'm missing some fancy thing. No, actually, I'm not. I just this one. The only difference, really, I don't even know if the player will notice that these pieces in the middle have that gray pixel at the level, and on the start it's a little bit higher. That's so small difference that the player most likely won't notice it at all. Here you can see that there's some other mistakes. Also, this tile seems to be in some. No, it is in the foreground. No, I'm just trying to place like this. Like this is the thing that I'm placing these by hand. The tile has a support for automapper, so you can make rules how the tiles should link to each other. And then you could just paint your level using some basic tiles, and then run the automapper, and then the automapper would then figure out how the tiles are supposed to be. Like I could, for example, I could let's say I could build this piece by just taking. We are just doing it in example here. I would like paint it like this, and then say the tile editor that hey, please beautify this one, and I would have written rules that would tell the automapper that okay, here we have a corner tile, so let's replace it with this one. Here we have a corner tile, replace it with this one. Here we have an edge tile, replace it with this one. Here we have more edge tiles, but these are at the top, so we are going to use these three here. So it would automate that part of the level design. I could just say that this part is ground, and then the program would make me all these corner tiles, and it could also do this stuff. Like here are all the tiles here in the middle. It looks boring if they are all the same. So I could have random info there that pick from this set of tiles, and it will place stuff. So it would randomize what gets placed here. I think I could even make skull that is in 2 tiles to randomly appear there. And if we check this bridge here, yeah, you can see that here we have some mistakes too. But it would be much easier if I wouldn't have to do this by hand like that. I think there wasn't. Actually, there's another one here. This one, I think I will just use this one all the way. I don't know if I should have a special tile here. Maybe not. because going through all these corners and bends and things, like here we have just a few pixels difference. It makes the level look nicer, but these are annoying to place, and I always forgot to place some of those. So all those that should be automated. Maybe I'll do that in the next tile thingy that I'm working on. Not on this one. Anyway, so that's what I have been working on this week. Just getting things animated, getting new tiles done, and then slowly starting with the user input. Excuse me. And the next step is to get the user input working and have our hero. I will be happy if in the next week I get the hero to walk around on the level, go up and down the ladders, and maybe even these ramps, because these ramps are going to be interesting because these are in the foreground. Foreground is what I'm going to use for the collision detection. So when the player falls, they stop at this. So when the feet touches this pixel, they should stop. But here they have to, when they are walking here, it's easy, but when they come here, they should start going up and then they should continue here. And then I have to figure out which point exactly I am going to count. Like as soon as their toes hit here, should they start going up? Or as soon as their heels hit here, or middle of their feet? And then how about when it's going up, and how about when it's going down? So I probably, like if I were to use their toes, then the going up would look pretty okay. But when they are coming from this direction, then they would sink into the stairs. So then I would have to use the heels, then it would look nice. But if I do it like that, then I have to keep track on which direction the player is facing, and then based on that information decide what part of their body should touch the stairs for the stairs to count. So if I use the heels, not heels, the middle of the feet, then it works equally well or equally bad, whichever way you look at it, regardless if they are going up or down. So that is going to be fun. And another thing is, how about the stairs? Like if the player is here and presses down, nothing should happen. Yeah, makes sense. If they are here and they press down, they should start climbing down. But what about when they are here and they press down? At what point can they go down? Do I really want to be pixel perfect before they can go down? No, I don't think so. So there needs to be some area here where they can go down. And when they start going down, should I center them on the ladders, or should I let them to use ladders so that they are a little bit on the side? Because if I allow that, then they clip the wall here, and I don't know what that does to the collision detection. And when they are climbing the stairs, can they suddenly decide to go left or right? Because if they can, then I have to figure out what happens here if they press left or right. Maybe they cannot move sideways on a place like this, but when they are in a place like this, then they can move sideways. Because I personally don't like games where you have to climb the stairs all the way down before you can dismount. I like when you are here and then you can just hop off. Or even if they are here and then they press the jump, what happens? Do they jump upwards? Does nothing happen? Can they jump sideways like this? And player is 32 pixels tall, 16 pixels wide, so they are occupying 2. So when they are here and press right, what happens? When they are halfway here, so they are taking these, and these, what happens? Can they dismount by going right or left? All that things. It it seemed so simple when I thought that yeah, just going to make some ladders and make the player walk there. But it gets complicated. And can they walk off the ledges? Can they jump off the ledges? Yeah, I think so. Which raises another question. What happens when they walk off from here? Because then they just fall into the void. Maybe I just spawn them back into the starting spot at that point. But I'm happy if I can get the player to walk back and forth in the next week. Okay, that's about it. Have a good one.